Now, Conic sections, sheet number 21. The axis, directrix, and a point P on the curve. So axis, directrix, and a point P on the curve of hyperbola are given, and the eccentricity of the curve is 1.5. That's going to be important. Part A of the question says locate the focus and vertex of the hyperbola, and part B, draw a portion of the curve to pass through point P. Let's get started. Eccentricity is the relation of the distance from point to focus over point directrix. It is also rise over run. We need to change our 1.5 into a fraction, and that is going to be 3 over 2. So the distance from point to focus is 3 units, and the distance from point to directrix is 2 units. That's going to be equal to the rise over run. Let's get cracking on this one. So the point to the focus we don't have, because we don't know where the focus is. It's down here in the vertex someplace. But the point to the directrix we do have. Point focus is 3 units, point directrix is 2. So the distance from the point to the directrix there is 2 units. I want to see what 1 unit looks like. So I'm going to bisect the line. Take it down onto my line. And I have 1, 2 units. I'm going to add a unit on and make it 3. So I'll just take 1 unit, add it on around here, and the total distance then from the P out is 1 unit, 2, 3. And by doing that, I have just set up a focal point right here, which gives me a ratio of 2 units to the directrix and 3 units down to the focus. I'm now going to set up my line of eccentricity. So rise 3, run 2. So I want to run along 2 units. I'm going to go along to 80. So 2 40s is 80. And at that point I need to rise up by 3 units. So 3 40s is 120. I'm really close to the text here. That's okay. So rise over run. There we are, line of eccentricity, And what are they asking us then? Locate the focus and vertex. Focus is done. Vertex 45 and drop. There's our vertex. Draw a portion of the curve to pass through point P. So just draw this portion of the hyperbola. First off, the focus brought to the line of eccentricity gives us a point on the curve. The focal line there will extend that lattice rectum all the way up, and we will pick some points, and it's going to drop a random point here, and I might just space out there. That's going to fall really close to point P, which I already have. I'll just go 30 and 45 here maybe. There is a chance I'm going to go right into the text now, up to the line of eccentricity, and across to the lattice. Up to the line of eccentricity. I might just drop one more actually in here a lot closer. And from the point on the line of eccentricity across to the lattice. Finally, from our focal point, along our lattice, drop down onto our ordinate. That's really, really close to the line of eccentricity there. And there we go. To complete this question, I might just mirror the points down through the axis. taking my lattice rectum, point exactly on the line of eccentricity where it is tangential to the curve, and finally taking my front point right there. And there we go. There's the question answered. So, given a point in the curve, a directrix and an axis, we can use our eccentricity ratio, PFPD, to figure out if this is 2 units. When we add a unit on, we can swing our 3 units to get our focus, and then we're back to our usual method for finding the rest of the points on a portion of that hyperbola. I hope this video helps, and thanks very much for watching.